Okay, so what we're going to be doing is continuing our states of matter notes. We are specifically going to be talking about what delta H vape is, and then we're also going to be talking about endothermic and exothermic reactions, and really reviewing what we did with endothermic and exothermic reactions. Okay, so we're going to take a look here, and we've already talked a little bit about solids, liquids, and gases, and the model for liquids, and we were talking about boiling point, and also did a quick little boiling water with ice lab as well. So you should be working on that too. And now this question is asking us something to start off here, just a question to kind of get you thinking a little bit. I don't know if you've heard this before, but does anyone know what is actually a worse burn? If you got a burn from steam or if you got a burn from putting your hand in boiling water? Does anybody know which one is supposed to be worse? Oh, good, steam, yes, it's true. One of the other classes had never heard that before. So, and the question is why? Well, we know back when we were doing phase changes and we looked at like a phase change diagram, and we said that the phase change, where the phase change happened, our temperature remained constant. So if water is boiling, then it should be staying at 100 degrees Celsius. So whether it's the liquid or the gas, it would stay at 100 degrees Celsius. So you would have liquid and gas staying at 100 degrees Celsius, and until you've converted all of the liquid into gas, and then what starts happening? Then your temperature starts rising again, increasing again. Perfect, okay? So this is weird, because if they're both at 100 degrees Celsius, then why is it that steam would be a worse burn, okay? So which type of burn is more severe? It's actually an equal mass of steam at the same temperature. If they're at the same temperature, then what is equal? What do you remember? What did we say? If they're at the same temperature, then they have the same average something? Kinetic energy. Awesome. Then the average kinetic energies are also equal. But here's the difference. The kinetic energy is the same, but guess what steam has a higher value of? What's the other kind of energy? Potential energy, okay? The potential stored energy of steam is actually much higher, and so that's why that burn would actually be worse than even though they're at the same temperature, okay? So let's take a look at this. This is called delta H vape, okay? And we know the delta stands for change, and what do you think this H stands for? Heat, very good, heat. And what about vape? Vaporizing, good. And vaporizing, we know, is just simply changing from liquid into gas. Okay, so this is called the molar heat of vaporization. So molar refers to having the quantity of 1 mole, which you remember how much a mole is? 6.02 times 10 to the 23rd particles. Remember, it could be anything in fame. The second word is heat, and heat is simply exchanging what? What's another word that you usually use for heat? You could say energy, good. And vaporization is the conversion of a substance, we already said, from liquid to gas. In other words, if you put it all together, the delta H vape is the energy needed or absorbed, well, when you vaporize molecules, if they're in the liquid state. So if you have molecules in the liquid state, and you turn those molecules into the gas state and you boil them, what have you done to the IMFs? You've broken them, okay? So what we've done is we've actually separated, to separate 6.02 times 10 to the 23rd, which is how much? 1 mole of any substance without changing the temperature, okay? So without changing the temperature, this is what delta H vape stands for. So it's the amount of energy that it takes. If you have a mole of a liquid substance and you convert that into a gas, how much energy does that take in order to get it to vaporize? That's basically what it is, okay? So it says when water changes from liquid to gas at constant pressure, what do you have to do? Well, if you want to boil the water, where do you put it? On a hot plate or a stove. Perfect, which means energy must be supplied. Okay, and then what do the molecules do to that energy? They absorb it, right? They take it in. Those molecules are going to take that energy in and absorb that energy. Okay, but the boiling remains constant until all of it has converted into gas, and that's what we had called the Britney Spears effect. At one temperature, different substances do have different vapor pressures. In other words, I could have 3 different containers, A, B, and C. Let's say in one of them I put acetone, like a nail polish remover. In another one I put alcohol. In another one I put lemonade. Those are all going to be vaporizing at different rates, okay? And so what we say is their vapor pressure. Do you guys remember what the vapor pressure is? It's just the pressure of the gas, of the vapor. It's the pressure of the gas above the liquid. Different substances will have different vapor pressures, okay? The amount of vapor above a liquid depends on really the types of attractive, which we call what? IMFs. And just like we said, the reason why something is a gas, a liquid, or a solid at room temperature is all based on what, everybody? IMFs. Awesome. It's all based on the IMFs, okay? So it depends on what types of IMFs that it has. Delta H is measured in what we call kcals per mole. Well, what is a kcal? Well, you've heard what a calorie is, right? You know what a calorie is? We use those in food, yes? Okay. But our calorie is actually, a food calorie is different from the science calorie. So what is a calorie? So you've heard of this calorie. Does anybody know what a calorie is? So it says that it's the quantity of heat needed to raise the temperature of, does anybody know this?
Isn't it like 1 gram of water by 1 degree Celsius?
Awesome. It is 1 gram of water by 1 degree Celsius. Now, water has a density of 1 gram for every milliliter. So if we look at this graduated cylinder, we're really talking about down here is basically about 1 milliliter, right at the bottom here. So if I put a milliliter of water, a gram of water inside of here, and I threw a thermometer in there, and I started to heat it, as soon as it went up by 1 degree Celsius, how much is that? How many calories is that? That's 1, okay? So that's how the calorie is defined. So raise the temperature of 1 gram of water by 1 degree Celsius. Now, it's important to know that the food calorie, they use a capital C on. And that refers to having, does anybody want to guess, how many lowercase c calories? It's actually 1,000 of them. In Europe, on the labels, on their food labels, they don't use the capital C calories like we do. They just call them kcals. They call them kilocalories, and we know that kilo would always be 1,000 of the base unit. So to say that 10 grams of sugar has 41 calories means 41 calories. Well, what do you do when you burn inside of your body? What's going to happen is it's going to release and give off that energy so that you can use it. So that amount of heat is released when 10 grams are completely burned to CO2 and H2O. Okay, the delta H vape for water, or the energy absorbed to change water molecules, what did we say vaporizing is? Changing from what to what? Liquid to gas, yep. Is 9.70 kcals per mole. Okay. Now this number's not going to really matter, but I'm going to show you when we start talking about delta HF how it's different. Okay, so we'll come back to that in a different lecture. When gaseous molecules condense into the liquid phase, it's still the same amount of energy. It's the same amount of energy to go from liquid to gas as it is to go from gas to liquid. Guess what the only thing is that's different about the number? The number is the same. What's the only thing that would be different about the number? Take a guess. Positive or negative? Yep. The sign is the only thing that's going to be different. Okay. So if energy is released, anybody want to guess what lost and released? And we're going to talk about this in a second. What sign you would get if something's lost or released? Give it a sign. It's actually negative, because if you're losing something, then if you think of it as being negative, that's going to be negative. And then if it's gaining or absorbing, that's going to be positive. Okay, so this one actually does work, because usually in chemistry it's the opposite. In this case, it's not. Okay, so losing is going to be negative and gaining is going to be positive. So when gaseous molecules condense, the same amount of energy, instead of being absorbed, would now be released. Because the energy is being lost, the value for the delta H of condensation, so instead of vaporization, we use condensation. It's the same number, it's 9.70, but because it's being released, the sign would be negative 9.70 kcals per mole. Okay, so this happened to me. It says, for dinner you got to watching Friends, and you were going to boil some potatoes, and then you forgot to even put the potatoes in, and then you were watching Friends and completely forgot about it, and then all of a sudden the smoke alarm goes off, and you almost cause a fire in your apartment complex. So this happened to me when I was in college, my roommate and I. So all the water has now evaporated. How much energy was used to boil the water to dryness? Okay, so this is the only math that's in this unit, okay? This is it. This is the only math that's in this unit. Circle what you want, write what you've got, throw in a bridge, and cross your units opposite, okay? So we're going to circle what we want. We want energy, but energy isn't a unit, okay? So I know that my pot has 250 mils of water, 250 grams, and then I'm seeing this delta H vape, 9.70 kcals per mole. Do you see an energy unit? The kcals. kcal is an energy unit. Joules and kilojoules will also be energy units. So we're going to use the kcals. So since that's what I'm looking for, I'm going to circle it. Do you remember if you're ending with one unit, you want to? Do you remember? If you end with one unit, you should be starting with one unit, okay? So if I'm ending with one unit, I want to start with one unit. This is a ratio. So a ratio is going to be 2 units. So do you see where I have 1 unit? What would you want to start with? The water, the mils of water. Do we want mils or grams? What do you think is easier? Why grams? Because then you can convert to moles. Awesome, perfect. Okay, so what we're going to do is we're going to start with the 250 grams, and it has a decimal point at the end of the water. Throw in a bridge, cross our units opposite, which means the grams of water come down here. Where do you go from grams? To moles. And do you remember the molar mass of water? 18, good. 2 plus the 16, so we're going to get 18.0. And even if you add the 0.01 on the hydrogens, we still stop at the 10th place with our adding rules for 6 grades. And now I'm in moles, and so I cross that opposite. Does anybody see something else in the problem that we can use that will get us to kcals? Yep, the 9.7. The delta H vape right here is 9.70 kcals for every 1 mole. But I don't have 1 mole. I have 250 grams. Okay? So that's what it is for just 1 mole. So what do? I'm just going to multiply this. And just because I did this before, you get 134.7 something, which would be, how many sig figs? 3, 3, and 3. So we would round that to 135. 135 kcals. Okay, so let's just sum this up. So vapor pressure is the pressure exerted by the vapor, but what's the other word that we're going to use? By a gas, in equilibrium with its liquid phase. The vapor pressure of a liquid depends on 2 major things, okay? One, it depends on what temperature you have surrounding it. So what is the temperature of the environment? That's one thing that it depends on. The other thing, they call the nature of the liquid, but you're going to be more specific here. What is the reason why something exists in the gas, the liquid, or the solid state? It's all based on its IMFs. Awesome. So the nature of the liquid is really its IMFs. Okay, that's what we're talking about there when we say the nature of the liquid. At any one temperature, different liquids have different vapor pressures. We said that. So some substances will evaporate faster, and some substances will take longer. It depends on how strong or weak their forces are. And as temperature increases, the vapor pressure always increases for every liquid. Okay? All right, so we're going to take a quick break. That's basically it in talking about delta H vape. Thank you, everybody.